And we're live. It's 9:28. I think I had originally put 9:24 and I had to change it because I forgot what period I was in. Look at the drip. Joe, what are you talking about? I don't understand this modern lingo. Kids with your whatever. Just, I don't know. Anyway, I see like 4 people in the live stream. We have way more people in the class than that. What is he talking about? Are you quoting something? I don't know what he's talking about. Somebody explain what Joe's talking about. But anyway, as I said in my post to the Google Classroom, I was going to allow people a few minutes to kind of get in. Obviously, there are way more than 4 people in this class. What? Go away, Joe. Anyway, so now there's 5 people. So yeah, I'm giving people a few minutes to kind of get in. I'll kind of talk a little bit about what we're going to be doing today, and what the next couple of weeks have in store for us. Actually, no, let me talk about that first. So what the next couple of weeks have in store for us, before I get into official class business. We have 2 days this week in class, 2 days next week in class. The 2 days next week in class, my goal is to review for said midterm that you have the week of the 25th. Now, this is going to be a strange couple of weeks indeed, obviously, since you guys are all quarantining. Supposedly. Whatever. I don't know. I'm sure. It's such a weird time. I don't know if you all read the letter that was sent out in regards to the justification behind quarantining, but it just felt like, hey, the region, their numbers are going up, and then the surrounding towns, their numbers are going up. So we're going to quarantine. Like, come on. The numbers are rising. If you looked at the weekly Cali score that's put out by the Department of Health, you know that the numbers are rising. The percent rate of COVID-like illnesses, the percent positivity rate, it's all rising. So we'll see what happens. Supposedly, the plan is that we will all be back live the week of the 25th, which is the week of midterms. Who the heck knows at this point, but we'll figure this junk out. Anywho, I know I have 7 people in the chat. Again, there's way more than 7 people in this class. Oh, it just jumped to 9. Well, there we go. So yeah, I don't know what day. I think I know what day your midterm is. I just need to look it up. But yeah, we got the next 2 weeks. We got 2 weeks, 2 days this week, 2 days next week to review. I'm going to be putting out an assessment this week to kind of wrap up the first part of this chapter. And then we'll be reviewing next week, and we'll figure that junk out as we go along. It's going to be oh so fun. It's really weird just teaching to an empty classroom. My biggest fears are coming true that I'm losing my mind. But that can't possibly be true, because how could you lose something that you never had? But I digress. Back to class. So in regards to you guys, what I'm going to ask you to do, and I was kind of delaying this because I was trying to get more people to kind of join into the chat, and I'll remind you it's probably before the end of this class period as well. For my sake, for an attendance, because they're asking that I do keep track of this stuff, especially over the course of the next 2 weeks. But I'm going to ask that y'all leave a comment in the live chat. Just give me some kind of a comment in the live chat with your real name, not your fake YouTube name, but your real name, obviously, because, you'll be in your school account. Right? Just leave me a comment. Hello, hi, how are you? That kind of thing. Just so I have a record as to who is here and that kind of thing. You see, like, I don't know who that is. Sports Gaming 23. No clue who that is, Oh, message retracted. Yes, again, yes. Obviously, switch over to whatever your school email account is for this, and that would be sufficient, obviously, because then I can actually see what y'all real name is, and that'd be great. So we'll figure this junk out. Anywho, as for today, we are going to be continuing with what we started at the end of class last time, talking about nth roots. Eventually, this is going to set up something huge for after midterms. This is going to set up something very huge. My plans, what I had hoped to accomplish over the next couple of weeks, obviously did not come true, simply because, well, we are all quarantined. So we've had to adjust like crazy, which is also fun, just to adjust on the fly. But we'll figure that junk out. Anyway, what I'm going to need from you, if you do not already have them out, I'm going to need those notebooks out and open. Mr. Markey, we already have our notebooks out and open. Oh, what good students you are, already having those notebooks out and open. I don't know. There we go. I gotta switch my screen over. Ba-boom. Aha. Now, just for the sake of argument, in a few minutes, I'm gonna have the chat open on my phone so that I can see what y'all are doing. Or if you have any questions, of course, I can answer them on the fly. I just wanted to share a picture this morning of my son. I'll zoom in on this so you can see it a little bit better. You're looking at a screen of a screen of a screen. Let's see how well you can see that. I'm going to focus the camera a little bit. Focus. There we go. I don't know. This is quite possibly a picture that I want to get framed of my son. I don't know how well you can kind of see it. You can kind of see it a little bit. Going to say anything? What? Anyway, you can't really see it that well because obviously you're looking at a screen of a screen of a screen. But this is my son jumping on his Christmas present. Well, it was a Christmas present for him and his sister. A trampoline that I built in the backyard. Our backyard borders a golf course, so there's like nobody behind us. And it was a particularly cold, frosty day, so you can't really see it, but there's like frost all around here, frost all over the golf course. And this kid goes out at like 7 a.m. and is just happily bouncing on that trampoline in 30-degree weather or 25-degree weather or whatever it was this morning. I thought it was pretty awesome. No, I just wanted to share that just because y'all are stuck inside. And my son is stuck inside too. He's stuck inside too. But the difference, he's doing school on the computer in his room. But the difference is that this kid finds ways to get outside no matter the weather, no matter the circumstances. So y'all should take that as a whatever. I don't know. How do I get into this thing? I'm trying to get into the live stream right now on my phone, and it's not working. Oh, I got to click that thing. Okay, I clicked that thing because I got to see your comments if you have any questions. Boom. Okay, no, not that one. Live. No, not that one either. Where the heck are you? Boom. There you are. Nailed it. Okay, good. Sorry, I was just trying to get the live stream up so I could actually see this. Sorry, I'm actually looking at your comments, though. The good old days, I remember when I used to be happy. What in the world are you guys talking about? You're making me sad. No, you can't make me sad. I need to have a heart first. Anyway, to this. We are doing nth roots continued. Nth roots continued. Today is the 12th. We're going to continue with this junk. And again, like I said, I can, if you do have any questions, I can see in the live stream right there. No, I will not face you in Call of Duty. I'm more of a Nintendo guy. Oh, goodness. I like to speed run Nintendo games. Now back to this. Now, just for the sake of argument, in your Google Classroom live stream, which is right here, I posted two things. One on January 8th, there were two PDF files. One of them was entitled 6.3 and the other was entitled 6.4. At some point, I'm going to be referring to these 6.4 problems. I am going to be referring to these 6.4 problems. So just so you know, if you can't see them that well from where you're sitting, obviously, you could always see this PDF. It's in the Google Stream. The other thing is this benchmark, which, again, I know, benchmark. I left an explanation in there, so you can see that when you get there. Joe, I would wreck you in Smash. That's all I'm gonna say. And I'm the only one with a voice now. So anyway, okay. For the sake of argument, let me just show you something very basic here. Sorry, again, I'm just reading the comments. Square root of x squared. Now, in terms of nth roots, the goal of today is to be able to simplify these things down. And I want to show you specifically what is going on in the inner workings of these problems. Because if you can understand what's going on in the inner workings of these problems, then you can apply that to any one of these things. So for example, the square root of x squared. Now, last class, I showed you something very basic in terms of what happens with fractional exponents. And I'm actually going to write this on the board off to the side so you can see that over here. Yeah, I'll put that right there. What I wrote last class was this. A to the m over n power. A to the m over n power. I don't know who that is. That last comment that popped up. He's going to have to switch over to a school account. Anyway, a to the m over n power. I told you to remember that m over n power as the phrase power over root, because the root is whatever the bottom of that fraction is. And it would be the nth root of a raised to the m power. Now, I'm going to leave that on the board off to the side because I'm going to be referencing that. And that is going to help us understand what the heck to do when we're faced with a problem like this. Now, a lot of you may look at this and be like, yeah, I already know what to do. I know. But bear with me. I'm trying to lay the groundwork for more difficult problems in a few minutes. Power over root. It's the nth root and the m power. Now, in this problem right here, this is obviously a square root, and there is no little number written there. But that little number, you should understand that if there is no number written there, you have to assume that this is a square root. There's a little 2 there. So, based on what I wrote in red on the board, I can change the way that this problem looks to be x squared to the 1/2 power. X squared to the 1/2 power, because that square root is nothing more than a 1/2 power. This goes a long way towards understanding how to do these problems. It really does. My screen froze. Hold up. Click and click, click and click. There we go. Now, based on everything that we've been doing with exponent properties, because I spent an entire class period going over the different exponent properties that you would need to know for this particular chapter. Based on everything that we've done, well, power to a power, I'm supposed to multiply those two exponents together. Well, that would be, 2 times 1/2 is just a 1, or just an x. Now, this should logically make sense, because when you square root a square, they cancel each other out. When you square root a square, they cancel each other out. Now, this logically comes into play with numbers as well. So for example, and this is something, again, I'm working towards the inner workings of the stuff. I'm doing stuff that's like, oh, that makes sense. Oh, that's why it works? Yes. Hold on. The square root of 64. Now, we've done the square root of 64. We know what the square root of 64 is. I spent such a a long time talking about the square root of 64 is 8. Why? Why is the square root of 64 8? Because 8 squared is 64. Yes. Hold on. I mean, everything I just said was completely true. But let's apply it to what we're doing today. Because what we're doing today, you're going to see some more intense problems. And you need to know what I'm throwing at you right now. In reality, 64 is 8 squared. 64 is 8 squared. Yes, that's true. We know that. Because the square root is really to the 1/2 power. Power of a power, they cancel each other out, leaving you with the 8. Now, this might seem ridiculous for me to show you, because in reality, in real life, you'd be like, oh, the square root of 64 is 8. Done. I know. But understanding what I just did is going to have long-term ramifications on this chapter. Understanding what I just did and why I did it is going to help you down the road with some of the more complex problems that you are going to be faced with. We know the square root of 64. Well, hold on. Take a step back. 64 is 8 squared. Yes, okay. That square root symbol is a 1/2 power. Okay. Power of a power, we multiply the exponents together. 2 times 1/2, leaving you with just the 8. This is the reason why it works. And like I said, understanding this process is going to apply to other problems in a little bit. This is the concept of nth roots. So now I can throw a problem at you like this. Negative 4th root of 256. The negative 4th root of 256. Now, I don't know many people who know this answer off the top of their heads. I don't. I really don't. Clearly, we could just use the calculator to get this thing done. And I will. Hold on. Let me just do that. Let's see. If you remember from last class, this is kind of a little bit of a side note reminder from last class. If you want to do a 4th root under the math function, which, by the way, I'm going to have to put a negative first because it's the negative 4th root. Negative math. The option right there that says x root. You could put that negative in the wrong spot. You know what? I'm just going to delete all that. I'm just going to go to the x root, and I'll just make the answer negative when I get there. 4th root of 256. I'll just put the negative out front once I actually know what the answer is. But it should be 4. Yay. Oh, happy day. We know the answer is 4. Okay, but check this out. 4 times 4 times 4 times 4 is 256. Or another way of putting that, 4 to the 4th power is 256. Now, all these things I can show you visibly right there. Fantastic. But let's apply it to what we were just doing in our notes. 256 is in reality 4 to the 4th power. Negative 4th root of 4 to the 4th power. Now, I'm not going to change it to the fractional exponent, but we should recognize the fact that a 4th root and a 4th power cancel each other out. So since they cancel each other out, I am left with a negative 4. This process is a little bit convoluted, but like I said, it's going to come into play. Now, one may ask the question, Ms. Margie, why can't I just use the calculator for all of these problems? Like, legitimately, why can I not just use the calculator for all these problems? That's a great question. I'm glad you asked it. It's so wonderful to know that students are thinking about that kind of stuff when I throw them this problem. The 5th root of 243 times x to the 10th power. This is the type of problem that you can't do on the calculator. This is the type of problem where the calculator is going, if you attempt to do this in the calculator, it will spit out the wrong answer. Guaranteed. Let me show you. Clear that. The 5th root, so I'd go math, x root 5, 243, x to the 10th power. Chapow, chapow. Ooh, that is not the answer at all. At all. I don't know what the heck that is, but that is not what we're looking at. Chapow. Instead, I'm going to have to change some stuff around. Now, 243. I don't know what, oh, excuse me. I don't know what the heck is going on with 243. But let's try to break the number 243 down. And when I say break it down, I mean by prime factorization. You could break down the number 243. Now, you can't divide it by 2, but you can divide it by 3. And you can break this number down as far as it can go using prime factorization. In fact, 243 divided by 3, divided by 3. Come on, divide by 3 again. Divide by 3. There we go. Divide by 3, divide by 3, divide by 3. It doesn't take too much of an effort to figure out that 243 is 3 to the 5th power. Let's use that in our problem. If I can change this 243 to be 3 to the 5th power, now I'm on my way. Now I'm on my way towards solving this problem. Oh, Joe, don't worry about it. I'm used to it. But check this out. I am utilizing those exponent properties that we've done in the past. The 5th root is nothing more than a 1/5 power. Because, again, I'm going to walk up here to show you what I wrote in red. The nth root is the bottom of that fraction. So if you were going to take a 5th root of something, it is the same process as raising something to the 1/5 power. So I am within my right to change that fifth root, that fifth radical, into a 1/5 exponent. So I can actually continue with this, and I can distribute that 1/5 power. Because again, this all boils down to the exponent properties that we did, and we probably did these before break, so a lot of these are hopefully coming back to you. But this 1/5 exponent, I am allowed to distribute to this problem. There's multiplication. I am only allowed to distribute that exponent under the guise of multiplication or division. Those are the only situations I can do that. I cannot distribute that exponent if this were a plus sign or a minus sign. Can't do it. But here I can. And since I can, this would become, and I'm doing this the long way so you can see the thought process behind it. 3 to the 5th to the 1/5 times x to the 10th to the 1/5. In reality, if you truly understood how this stuff works, you would have gotten the answer in like 15 seconds. But I'm showing you the nuts and bolts of this, and I'm showing you the logic behind each minute step that I'm taking. Let me recap, because I'm almost done, but let me just recap what happened. What the heck is 243? I don't know. But it only took me a couple of moments in the calculator to figure out through prime factorization that 243 is 3 to the 5th power. Cool. I can change that fifth root into a 1/5 exponent. Awesome. I can distribute that 1/5 exponent. Wunderbar. Power to a power, power to a power. 5 times 1/5 cancel each other out or give you a 1. 10 times 1/5 gives you a 2. So this becomes 3x squared. Done. That's what this answer is. That is the final answer to that particular problem. Your calculator is not going to give you that. I'll just use photomath. Okay. You can do that. That's not going to help you with future problems, though. What happens when you're faced with a word problem? A word problem that doesn't show up in any Google search. And you're going to be forced to do this thing by yourself. What if you're doing the midterm and you try to photomath or try to Google stuff in the middle of it? Oh, sorry. Doesn't work. Oh, you're screwed then. We need to put in the work now to make it easier later on. Let's try another one. Flip my page over. Let's see. There's a wonderful problem. Oh, there's another wonderful problem. I would like to do that one then. Yes, I would like to do that one. Okay. This is going to be a weird problem. This is from that worksheet, like I said, that I posted in the Google Stream a while ago. It's got a lot of great practice problems. The cubed root of negative 64 r squared times w to the 15th power. Now this one, I am going to handle a little bit differently because of the nature of the problem. This one I'm going to handle slightly differently. First, think about what we have on the inside of that radical. On the inside of that radical, we have a negative 64. Well, I know what 64 is. 64 is 8 squared. I know that 64 is 8 squared, but that's not going to help us. That is not going to help us. The reason why it's not going to help us is because you don't have a square root. You have a cube root. So we have to handle this problem slightly differently. We do. There's a negative in there. Well, Mr. Markey, I thought you couldn't take the square roots of negatives. Correct. If you try to take the square root of a negative, it gives you a complex answer. But this is not a square root. This is a cube root, which I can do of a negative. Negatives are allowed to be taken odd roots of. And then this weird r squared. Well, again, that's square. Oh, it's not going to cancel out with a cube root. And then I got that w to the 15th, which is like a wild card. Oh my gosh, I better phone it in right now. Well, hold on. Let's break it down piece by piece. As far as I'm concerned, there are 4 pieces of information. Okay, Joe, if you say so. I don't know what it means. I don't know what that lingo you're throwing at me is, but whatever. But there are 4 pieces of information inside of this radical. There's the negative, there's the 64, there's the r, and there's the w. There are 4 pieces of information inside of this radical that we need to concern ourselves with. So let's break it down piece by piece. We can't handle this problem in the exact same way that we did last time. We can't, unfortunately. But I am going to have to break this thing down piece by piece. Oh, Joe, with your teenage lingo. I don't know. I prefer being an old man. Anyway. 64. Yes, 64 is 8 squared, but that's not going to help me. So let's break it down even farther. Let's break down the 64 as far as it can possibly go using prime factorization. And if you did that, you would realize that 64 is nothing more than 2 to the 6th power. You could easily replicate that in a calculator. 64 is 2 to the 6th power. So again, let's break this thing down piece by piece. This is equal to the 3rd root. Oh, can't see it. Click. There we go. This is equal to the 3rd root of negative 1 times 2 to the 6th power times r squared times w to the 15th. Like I said, there were 4 things I was concerned with. One of them was the negative, which I made a negative 1. I changed the 64 into its prime factorization, 2 to the 6th. R squared and w to the 15th stayed the same. Now here's the weird thing that's going to happen. The really weird thing that's going to happen. You can take the cubed root of negative 1. You can take the cubed root of negative 1. Basically, you're going to be treating each of these terms like they were in their own separate cubed root. You can take the cubed root of 64. You can even take the cubed root of w to the 15th. Unfortunately, we can't take the cubed root of r squared. Let's see. I'm going to make this the cubed root of negative 1 times the cubed root of 2 to the 6th times the cubed root of r squared times the cubed root of w to the 15th. This just becomes -1, because I just showed you that on the calculator. -1 times -1 times -1 is -1. The cubed root of -1 is -1. This one, the 2 to the 6th, well, imagine you changed this to be a 1/3 power. If this were a 1/3 power, then this would become 2 squared. If it were a 1/3 power, which it is. And this same rationale, consider that cubed root to be a 1/3 power. It would really be w to the 15th to the 1/3, multiply the exponents, and you get w to the 5th. Well, what happens to that r? Unfortunately, sucks to be that r, but it has to stay inside that root. It is not allowed to escape at all. Can't do it. Sorry. So here's how we write down the final answer. The items that were allowed to escape, the negative, the 2 squared, the w to the 5th, I'm going to write them as normal. And the r squared, which unfortunately was stuck, which unfortunately was left behind, which unfortunately cannot escape, is just left where it is. That is how we write our answer. It's very strange to think about this process, but I like to consider what is and is not allowed to escape the radical. To escape the radical of a cube root, you need to be a perfect cube. To escape a square root, you have to be a perfect square. To escape a 5th root, you have to be a perfect 5th power. Again, with this problem, the only way you're going to escape this cube root is if you are a perfect cube. 2 to the 6th is technically a perfect cube, because you can break it up either as, well, 2 cubed and 2 cubed, or as we figured out, where's my marker? There, I'll use this one. As we figured out, 64, we figured this out actually last week, is really 4 to the 3rd power. And when you take the cubed root of that, you get that 4. That's just an alternate way of doing it. Let's just leave that be for the time being. Same thing with the w to the 5th. I didn't like this marker. I'm going to use this marker. Same thing with the w to the 5th. Originally, it was a w to the 15th, which is in reality w cubed, w cubed, w cubed, w cubed, w cubed. It's all of those w cubes. And when you take the cubed root of each of them, out pops a w. In fact, 5 of them, which is where this w to the 5th comes from. It's just an alternate way of looking at the problem. Unfortunately, there's no way for the r to escape. The r does not have the proper exponent to escape a cube root. And since it doesn't have the proper exponent to escape the cubed root, it remains locked behind that cubed root. This is the way that problem could be done. Of course, there are alternate ways of looking at it. There's always more than one way of looking at this kind of problem. Let's try something else. Let's try, I don't like that one. I don't like that one. I definitely don't like that one. You know what? I'm going to make up my own problem, because I'm a jerk. Example. This is going to be a little messed up. The fourth root of 32 x to the 8th y to the 6th. There we go. I'll zoom in on that. It is the fourth root of 32 x to the 8th. Let me fix that 8. There we go. Of x to the 8th y to the 6th. The only way you're going to escape a fourth root is if you are a perfect fourth power. If you took that 32 and tried to break it down, you would quickly find out that 32 is 2 to the 5th power. Now hold on. The fourth root of 2 to the 5th, x to the 8th, y to the 6th. Now, hopefully, it's very clear to see that none of them are a perfect fourth power. None of them. Perhaps you would be able to recognize that x to the 8th would be able to escape because if you changed that fourth root to be a 1/4 power, it would cancel out with that 8. However, what do I do with the 2? And what do I do with the y? Ooh. Well, here's, I don't want to call it the magic of math. I don't want to call it mathemagical. Let's just call it the thing that kids hate about math. There's always more than one way to do a problem. There is always more than one way to do a problem. And as a result, let's see what happens here. Check out this junk. Actually, you know what? I'm going to give you more room down here. Let me move that up to the top. I'm going to try and get out of the glare. Watch how I break this sucker down. I'm going to write it out. And then I'm going to explain what I did. Okay. Look at what the heck I just did. It's focusing. Sorry, the camera got all messed up for a second. First of all, 32, as you can see right there, 32 is nothing more than 2 to the 5th power. It takes a few moments with a calculator to figure that out. Just keep doing the prime factorization of 32. You do the prime factorization, you eventually get 2 to the 5th power. Yay. 2 to the 5th power, according to our exponent properties, can be broken up like this. 2 to the 4th, 2 to the 1st. That x to the 8th power up here can be broken up in the exact same way. X to the 4th, x to the 4th. Because the exponent property tells me that I can add those two exponents together. Same thing with the y to the 6th. I can break that thing down to be y to the 4th, y squared. Knowing these exponent properties is going to help with these problems. Now, I'm not going to write the next part out, but I'm going to verbalize this. I'm not going to write it out, but I am going to verbalize this. I could rewrite this whole thing as the fourth root of 2 to the 4th, the fourth root of 2, the fourth root of this x, the fourth root of this x, the fourth root of this y, the fourth root of this y. I don't want to write that out. I don't feel like writing that out. Instead, because of what I just did, I'm going to do a little trick. What I just did was I recognized what type of root it was and know that, well, in order to escape a fourth root, you have to have a fourth power. So I purposefully broke up these terms to get the maximum number of fourth powers. Unfortunately, this one right here doesn't have it. This one right here doesn't have it, but the rest of them do. And when I take the fourth root of 2 to the fourth, that thing pops out as a 2. Try to get the glare in the middle. Move that down a little bit. Whatever. This other 2, oh, sorry, you don't have it. This one pops out as an X. This one pops out as an X. This one pops out as a Y. The only way you're going to escape a fourth root is if you have a fourth power. And when that fourth root is applied to each of those terms, they lose their exponent. These other 2 are left behind. Watch how the answer is written. The answer is written as this: 2x squared y, because it was x times x. The fourth root of 2y squared. That's how that answer is written. It looks painful. It looks terrible. But that's the simplified version of this problem. Like, there are multiple ways to go through this process. There's way more than one way to go through this process. I'm trying to show you the most condensed version that you could possibly do, so you don't have to learn a million methods. Just learn the one that works. And if it works, it works. And if it doesn't work, then you got to try something else. This is life. Yeah. Oh, I got one for you. Oh, I got one for you. Check this out. Example. There we go. The square root of x squared plus 10x plus 25. Now I'm going to rewrite this problem, and then I'm going to explain something that you're not going to like. Let me rewrite this problem. X squared plus 10x plus 25. The whole thing raised to the 1/2 power. Now, this. First of all, this is a perfectly acceptable way for me to rewrite the problem. A square root is nothing more than a 1/2 exponent. Power over root. The root being, again, first power, second root. Perfectly acceptable. We did this in one of our previous problems. However, in our previous problem, I believe the previous problem I am referring to is the cubed root of 243x to the 10th. I believe that was the problem I was referring to. In that problem, we distributed that exponent. I believe it was a 1/5 exponent. We distributed it. Yay, and we all high-fived each other from a distance. However, I cannot do that here. Of course. No, but I can't. I'm not allowed to. See, according to our exponent properties, and we wrote these down into our notes before break, according to the exponent properties that we covered, distributing the exponent is only allowed if there is multiplication, division inside of the parentheses only. Only if there is multiplication, division within the parentheses. Unfortunately, there is addition inside of these parentheses. So I am not allowed to distribute this 1/2 power. I'm not allowed. Unfortunately, I can't do it. Sorry. Oops. At this point, people cry, shed tears into their paper. Oh, I guess we're done with this problem. Heck no, we're not done with this problem. Heck no. There's got to be something else we could try. There's got to be some other problem-solving technique that we can apply to this problem. There has to be something. Why would he throw this problem at us and make such a big deal about it if we were just going to leave the problem like this? What you have inside of the parentheses is quadratic. And what have we been doing with quadratics since the beginning of the school year? We have been factoring them. We have been factoring these quadratics since the beginning of the year. If you look at this quadratic just by itself, x squared plus 10x plus 25, you could apply whatever method of factoring you know. You can factor this thing into x plus 5 times x plus 5. Because 5 times 5 and 5 plus 5 work with this particular quadratic. So I can take this thing. What is this? Okay. I can take this thing and I can factor it into x plus 5, x plus 5, with that 1/2 exponent still there on the outside. Well, wait a minute. Isn't x plus 5 plus x plus 5, isn't that just x plus 5 squared? Well, yes, it is. With that 1/2 power still on the outside. Well, now I'm not technically distributing the exponent. I'm not. Instead, I was able to rearrange the way that this problem looks in order to get power of a power. As a result, I can multiply those two exponents together. They cancel each other out. And I'm left with x plus 5. That's what this problem is. See, these problems require a different level of problem solving. They require looking at them from a slightly different angle. I mean, they're all technically the same problem, but you have to look at it from a slightly different angle in order to recognize its weaknesses. That's what problem solving is. It's learning how to attack a problem, chip away at its faults until you can get down to its core and get the solution. People don't look at mathematics the proper way, in high school that is. They don't look at it the proper way. They don't look at it as proper problem solving. The only thing that most high school students think about is, how am I going to apply this to my real life? Guess what? You're never going to do this in your real life. What I just showed you right here, this math, you're never going to do that in your real life. However, learning how to refine your problem-solving skills, learning how to sharpen your mind, learning how to look at problems from a different angle and see if you can't whittle away at it until that solution shows up. That's life. This is the only class that does that for you. Help you to refine those problem-solving skills. I'm sorry if you're only looking for things that you can apply to life, but I'm looking at the bigger picture. Okay. I'm going to wrap up there. I'm going to get off my soapbox. I'm going to tell you this. Number one, that benchmark is still sitting in the Google Classroom. Read my explanation. Unfortunately, we have to get that done. But read my explanation. Get the benchmark done. We'll all high-five each other at the end. I'm going to continue with problems like this on Thursday. I'm going to be assigning you some kind of an assessment before the end of it, so we can knock another one of those things out. And next week, which I have you again on Tuesday, Thursday, because Monday you have off, but I have you again on Tuesday, Thursday. Next week, we're going to review for the midterm. Midterm is going to consist of everything we've done from the beginning of the year. If you have any questions in regards to anything that we've covered, of course, you can email me. And a reminder to every single person in the live chat right now, as I said at the beginning of class, I need you to comment in the live stream, because I can go back. This video will be uploaded directly to my YouTube. I need to double check because they're asking me to keep record of attendance. So if you have not, only if you haven't, because I've seen the people who have, but if you haven't commented in the chat, I need you to do so I can see who is here. Joe, I don't have a Discord for Smash. I don't play online competitively. I'm just saying that I would wreck you. So that's all I'm really saying. Anyway, I'm going to wrap it up there. You know, Joe, it's usually the people who respond like that are a bit more scared than others. All right. The difference between me and you, Joe, is that I don't have anything to prove. But I'm going to wrap up there. And like I said, I'm going to be double checking the chat afterwards. And yeah, pay attention to the Google Classroom, get my benchmark done, and we'll wrap it up there. Thank you, guys. Have a wonderful day. Goodbye, 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 goodbye. Get the heck out. Take your stuff with you. Don't leave it under your desk. Make sure you're social distancing in the hallways. And don't be late to your next class. The bell's going to ring in approximately, I can't even count right now, a minute and a half. But I'm going to end it there. Bye, guys. Bye, 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 bye.